Pnictogen. ʻnɪktədʒən/ʻnɪktədʒən/ is one of the chemical elements in group 15 of the periodic table. This group is also known as the nitrogen family. It consists of the elements nitrogen, phosphorus, arsenic, antimony, bismuth, and perhaps the chemically uncharacterized synthetic element moscovium. In modern IUPAC notation, it is called group 15. In Ca and the old IUPAC systems it was called group VA and group VB respectively. In the field of semiconductor physics, it is still usually called group V. The 5 in the historical names comes from the pentavalency of nitrogen, reflected by the stoichiometry of compounds such as N2O5. They have also been called the pentals. The term ʻnɪktədʒən is derived from the ancient Greek word ∑ meaning to choke, referring to the choking or stifling property of nitrogen gas. Like other groups, the members of this family show similar patterns in electron configuration, especially in the outermost shells, resulting in trends in chemical behavior. This group has the defining characteristic that all the component elements have 5 electrons in their outermost shell, that is 2 electrons in the S subshell and 3 unpaired electrons in the P subshell. They are therefore 3 electrons short of filling their outermost electron shell in their non-ionized state. The Russell-Saunders term symbol of the ground state in all elements in the group is 4s32. The most important elements of this group are nitrogen, which in its diatomic form is the principal component of air, and phosphorus, which, like nitrogen, is essential to all known forms of life. Binary compounds of the group can be referred to collectively as ʻnɪktədzən. The spelling derives from the Greek verb ∑ to choke or stifle, which is a property of molecular nitrogen in the absence of oxygen. It can also be used as a mnemonic for the 2 most common members, P and N. The name pentals was also used for this group at one time, stemming from the earlier group naming convention. Nictide compounds tend to be exotic. Various properties that some nictides have include being diamagnetic and paramagnetic at room temperature, being transparent, and generating electricity when heated. Other nictides include the ternary rare earth main group variety of nictides. These are in the form of Rhmk, where M is a carbon group or boron group element and Pn is any nictogen except nitrogen. These compounds are between ionic and covalent compounds and thus have unusual bonding properties. These elements are also noted for their stability in compounds due to their tendency for forming double and triple covalent bonds. This is the property of these elements which leads to their potential toxicity, most evident in phosphorus, arsenic, and antimony. When these substances react with various chemicals of the body, they create strong free radicals not easily processed by the liver, where they accumulate. Paradoxically, it is this strong bonding which causes nitrogen and bismuth's reduced toxicity, as these form strong bonds with other atoms which are difficult to split, creating very unreactive molecules. For example, N2, the diatomic form of nitrogen, is used as an inert gas in situations where using argon or another noble gas would be too expensive. The upper nictogens, that is, nitrogen, phosphorus, and arsenic tend to form 3 charges. Antimony and bismuth can either take on a +3 or +5, by losing its p shell electrons or losing its p shell and s shell electrons, respectively. Nictogens can react with hydrogen to form nictogen hydrides such as ammonia. The nictogens consist of 2 nonmetals, 2 metalloids, 1 metal, and 1 element with unknown chemical properties. All the elements in the group are solids at room temperature, except for nitrogen which is gaseous at room temperature. Nitrogen and bismuth, despite both being nictogens, are very different in their physical properties. For instance, at STP nitrogen is a transparent nonmetallic gas, while bismuth is a silvery white metal. The densities of the nictogens increase towards the heavier nictogens. Nitrogen's density is 0.001251 g/cm3 at STP. Phosphorus's density is 1.82 g/cm3 at STP, arsenic's is 5.72 g/cm3, antimony's is 6.68 g/cm3, and bismuth's is 9.79 g/cm3. Nitrogen's melting point is 210 degrees C and its boiling point is 196 degrees C. Phosphorus has a melting point of 44 degrees C and a boiling point of 280 degrees C. Arsenic is one of only two elements to sublimate at standard pressure. It does this at 603 degrees C. Antimony's melting point is 631 degrees C and its boiling point is 1587 degrees C. Bismuth's melting point is 271 degrees C and its boiling point is 1564 degrees C. Nitrogen's crystal structure is hexagonal. Phosphorus's crystal structure is cubic. Arsenic, antimony, and bismuth all have rhombohedral crystal structures. The nitrogen compound sal ammoniac has been known since the time of the ancient Egyptians. In the 1760s, two scientists, Henry Cavendish and Joseph Priestley, isolated nitrogen from air, but neither realized the presence of an undiscovered element. It was not until several years later, in 1772, that Daniel Rutherford realized that the gas was indeed nitrogen. The scientist Hennig Brandt first discovered phosphorus in Hamburg in 1669. Brandt produced the element by heating evaporated urine and condensing the resulting phosphorus vapor in water. Brandt initially thought that he had discovered the philosopher's stone, but eventually realized that this was not the case. Arsenic compounds have been known for at least 5,000 years, and the ancient Greek Theophrastus recognized the arsenic minerals called realgar and orpiment. Elemental arsenic was discovered in the 13th century by Albertus Magnus. Antimony was well known to the ancients. A 5,000-year-old vase made of nearly pure antimony exists in the Louvre. Antimony compounds were used in dyes in the Babylonian times. The antimony mineral stibnite may have been a component of Greek fire. Bismuth was first discovered by an alchemist in 1400. Within 80 years of bismuth's discovery, it had applications in printing and decorated caskets. The Incas were also using bismuth in knives by 1500. Bismuth was originally thought to be the same as lead, but in 1753, Claude François Gieffroy proved that bismuth was different from lead. Moscovium was successfully produced in 2003 by bombarding americium-243 atoms with calcium-48 atoms. The term ʻnɪktədʒən was suggested by the Dutch chemist Anton Eduard van Arkel in the early 1950s. It is also spelled ʻnɪktədʒən or ʻnɪktədʒən. The term ʻnɪktədʒən is rarer than the term ʻnɪktədʒən, and the ratio of academic research papers using ʻnɪktədʒən to those using ʻnɪktədʒən is 2.5 to 1. It comes from the Greek root pi nu iota gamma, and thus the word ʻnɪktədʒən is also a reference to the Dutch and German names for nitrogen. Hence, ʻnɪktədʒən could be translated as suffocation maker. The word ʻnɪktide also comes from the same root. Nitrogen makes up 25 parts per million of the Earth's crust, 5 parts per million of soil on average, 100 to 500 parts per trillion of seawater, and 78% of dry air. The majority of nitrogen on Earth is in the form of nitrogen gas, but some nitrate minerals do exist. Nitrogen makes up 2.5% of a typical human by weight. Phosphorus makes up 0.1% of the Earth's crust, making it the 11th most abundant element there. Phosphorus makes up 0.65 parts per million of soil, and 15 to 60 parts per billion of seawater. There are 200 million metric tons of accessible phosphates on Earth. Phosphorus makes up 1.1% of a typical human by weight. Phosphorus occurs in minerals of the apatite family, which are the main components of the phosphate rocks. Arsenic makes up 1.5 parts per million of the Earth's crust, making it the 53rd most abundant element there. The soils contain 1 to 10 parts per million of arsenic, and seawater contains 1.6 parts per billion of arsenic. Arsenic makes up 100 parts per billion of a typical human by weight. Some arsenic exists in elemental form, but most arsenic is found in the arsenic minerals orpiment, realgar, arsenopyrite, and enargite. Antimony makes up 0.2 parts per million of the Earth's crust, making it the 63rd most abundant element there. The soils contain 1 part per million of antimony on average, and seawater contains 300 parts per trillion of antimony on average. A typical human contains 28 parts per billion of antimony by weight. Some elemental antimony occurs in silver deposits. Bismuth makes up 48 parts per billion of the Earth's crust, making it the 70th most abundant element there. The soils contain approximately 0.25 parts per million of bismuth, and seawater contains 400 parts per trillion of bismuth. Bismuth most commonly occurs as the mineral bismuthinite, but bismuth also occurs in elemental form or in sulphide ores. Moscovium is produced several atoms at a time in particle accelerators. Nitrogen can be produced by fractional distillation of air. The principal method for producing phosphorus is to reduce phosphates with carbon in an electric arc furnace. Most arsenic is prepared by heating the mineral arsenopyrite in the presence of air. This forms As4O6, from which arsenic can be extracted via carbon reduction. However, it is also possible to make metallic arsenic by heating arsenopyrite at 650 to 700 degrees C without oxygen. With sulphide ores, the method by which antimony is produced depends on the amount of antimony in the raw ore. If the ore contains 25% to 45% antimony by weight, then crude antimony is produced by smelting the ore in a blast furnace. If the ore contains 45% to 60% antimony by weight, antimony is obtained by heating the ore, also known as liquidation. Ores with more than 60% antimony by weight are chemically displaced with iron shavings from the molten ore, resulting in impure metal. If an oxide ore of antimony contains less than 30% antimony by weight, the ore is reduced in a blast furnace. If the ore contains closer to 50% antimony by weight, the ore is instead reduced in a reverberatory furnace. Antimony ores with mixed sulfides and oxides are smelted in a blast furnace. Bismuth minerals do occur, in particular in the form of sulfides and oxides, but it is more economic to produce bismuth as a byproduct of the smelting of lead ores or, as in China, of tungsten and zinc ores. Moscovium is produced a few atoms at a time in particle accelerators. Nitrogen is a component of molecules critical to life on Earth, such as DNA and amino acids. Nitrates occur in some plants due to bacteria present in the nodes of the plant. This is seen in leguminous plants such as peas, such as spinach and lettuce. A typical 70 kg human contains 1.8 kg of nitrogen. Phosphorus in the form of phosphates occur in compounds important to life, such as DNA and ADP. Humans consume approximately 1 gram of phosphorus per day. Phosphorus is found in foods such as fish, liver, turkey, chicken, and eggs. Phosphate deficiency is a problem known as hypophosphatemia. A typical 70 kg human contains 480 grams of phosphorus. Arsenic promotes growth in chickens and rats, and may be essential for humans. Arsenic has been shown to be helpful in metabolizing the amino acid arginine. There are 7 mg of arsenic in a typical 70 kg human. Antimony is not known to have a biological role. Plants take up only trace amounts of antimony. There are approximately 2 mg of antimony in a typical 70 kg human. Bismuth is not known to have a biological role. Humans ingest on average less than 20 micrograms of bismuth per day. There is less than 500 micrograms of bismuth in a typical 70 kg human. Nitrogen gas is completely non-toxic, but breathing in pure nitrogen gas is deadly, because it causes nitrogen asphyxiation. The buildup of nitrogen bubbles in the blood, such as those that may occur during scuba diving, can cause a condition known as the bends. Many nitrogen compounds such as hydrogen cyanide and nitrogen-based explosives are also highly dangerous. White phosphorus, an allotrope of phosphorus, is toxic, with 1 mg per kilo body weight being a lethal dose. White phosphorus usually kills humans within a week of ingestion by attacking the liver. Breathing in phosphorus in its gaseous form can cause an industrial disease called phossy jaw, which eats away the jawbone. White phosphorus is also highly flammable. Some organophosphorus compounds can fatally block certain enzymes in the human body. Elemental arsenic is toxic, as are many of its inorganic compounds, however some of its organic compounds can promote growth in chickens. The lethal dose of arsenic for a typical adult is 200 mg and can cause diarrhea, vomiting, colic, dehydration, and coma. Death from arsenic poisoning typically occurs within a day. Antimony is mildly toxic. Additionally, wine steeped in antimony containers can induce vomiting. When taken in large doses, antimony causes vomiting in a victim, who then appears to recover before dying several days later. Antimony attaches itself to certain enzymes and is difficult to dislodge. Stibine, or SbH3, is far more toxic than pure antimony. Bismuth itself is largely non-toxic, although consuming too much of it can damage the liver. Only one person has ever been reported to have died from bismuth poisoning. However, consumption of soluble bismuth salts can turn a person's gums black.